I'm going to show you how to do assignment number 2, ionic compounds with transition metals or multivalent cations. Come on, let's go. Okay, so here we go. This is assignment 2, binary compounds with transition metals or multivalent cations. Okay, some things we need to remember, that the Roman numeral equals the charge or oxidation number. Okay, and that's for the metal. Okay, and here are our Roman numerals over here in case you're not Roman. I is 1, II is 2, III is 3, and IV is 4. Okay, so let's look at the first one. Now we're going to do the same thing we did with assignment 1. We're going to write the symbol of the metal. Copper is Cu, wouldn't want to be U. And sulfide means sulfur. Remember, it's on the ide side, sulfur. And there's copper right there. Now we look at the Roman numeral. This means it's a +1 charge. So copper is +1. And sulfur, as we recall, it's in group 16, and it has a -2 charge. All right, so now we are going to crisscross our charges. And so this 2 comes over here, and the 1 comes over there. We drop the signs. We drop the signs, and we don't write 1s. So this will be Cu2S. All right, let's do the next one. Iron 3 iodide. Okay, and we look, and there's the symbol for iron. Okay, and iron is Fe. Iodide, that means iodine, which is a halogen and a -1. This +3 here tells us that the iron, the Roman numeral 3 tells us iron has a +3 charge. Okay, so that 3 is going to come down here. I'm not even going to bother moving the 1 because I'm not going to write 1s. And that's a 3, not a 2. So Fei3. Okay, Cobalt Ii Oxide. And here's cobalt. Hopefully you wrote your charges on all your multivalent cations from the list on the back. And cobalt 2 has a +2 charge. As you remember, this list should be on the back of your periodic table. Or if you printed one at home, you should have this printed out as well. And so you find cobalt, there's cobalt 2, has a +2 charge. Oxide, that means oxygen, and oxygen is in group 16 or 6A and has a -2. Now we are going to crisscross our charges. A 2 and a 2. Can we simplify that? Why, yes we can. So this is going to be COO. This is one reason why it's very important for you to put capital and lowercase letters. Okay? So it has to be a lowercase letter there. All right. I'm going to skip down to iron 2 oxide, number 8. I'm going to do number 8 now. Okay, so iron, we remember iron is Fe for the Latin ferrum. And we look at ferrum, or iron. It can be a +2 or a +3. Well, this says iron 2, so it's going to be a +2. Oxide is oxygen, and it is still a -2. Remember, all the charges for your nonmetals are going to be listed right up here. Okay? So now we crisscross our charges. This 2 comes here, and that 2 comes there. And can we simplify that? Why? Yes, we can. So it's going to combine in a 1-to-1 ratio. And it says FeO. So iron 2 is ugly. No, it's not. All right. So now I want you to skip down to iron 3 oxide, number 10. Okay. And so iron is still Fe. The Roman numeral 3 tells us this is a +3 charge. And oxygen, of course, is still a -2. Now we crisscross our charges. And 2 and a 3, can we simplify that? No, we cannot. So that is our formula, Fe2O3. Okay, so the reason I did 8 and 10 is to show you both of them are iron oxides, but one has the iron 2 cation, and that's the chemical formula. This one has the iron 3 cation, and that's the chemical formula. These are two different compounds with different properties. So it's very important that we put the Roman numeral in the name of the element. Okay, so now I'm going to go to the other side of the worksheet. And guys, this is the hard part. This is going to involve a little bit of math and a little bit of thinking, but here's what we do know. We know the charge of the nonmetal. We know exactly what that will be. In this case, oxygen here is going to be a -2 charge. We know that. The copper, we don't know its charge. Okay, now we see a number 2 here, and what a lot of people want to do is they put copper 2, Roman numeral 2. That's not the charge. So what we do is we draw a line between our metal and our nonmetal, and I draw a line. I call this making the cross. You make the cross. Okay? Now, not only do we know the charge of oxygen is a -2, but we know the total positive charge must equal and cancel that out. So this has to be a +2. Okay? Now, that +2 charge is coming from 2 coppers. So each copper ion must be a +1. There are 2 +1s and 1 -2. So this one is going to be copper 1 oxide. All right, now let's look at the second one here. We do know the charge on chloride, and chloride's a -1, but there are 2 of them. So our total negative charge is going to be -2, because we have 2 -1 chloride ions there. That means this has to be a +2 to cancel the -2 out. And that -2 charge is coming from just this one copper ion. So this copper ion has a charge of +2. So this one is copper 2 chloride. Don't forget to ide the nonmetals, okay? So in the name, you must have a Roman numeral if it is multivalent, okay? I'm going to do a couple more here because these are pretty hard. This one here requires a lot of math, but that's okay. I'm going to help you with it. So oxygen, we know oxygen is a -2. And there are 3 of them because we see the 3 there. So this gives us a total negative charge of -6. Okay? So the positive charge over here must counteract that, so this has to be a +6. All right? But that +6 charge is coming from 2 iron ions. So we divide that by 2, and we get a +3 charge on each ion. So this will be iron 3 oxide. Now what some people think they can do is they can just reverse crisscross the charges. And this 3 goes up here to a +3, and that 2 goes to a -2. That would work on this one. but it would not work on this one here. This is why you need to work this out. So on this one here, there's one oxygen and one manganese. So is that manganese 1? No, it's not. So oxygen has a -2 charge. So this has to have a +2 charge. And that +2 charge is coming from just one manganese ion. So this is going to be manganese 2. That's your charge right there. Okay? Don't forget, Mn is manganese. Mg is magnesium. So think about it. If you went to Mangan, what language would you speak? Manganese. Okay, so now if that wasn't hard enough, here's one thing about this worksheet. There are a couple of compounds on here that are not multivalent. If you watch the video on multivalent cations, you would know that group 1 metals are not multivalent. They're always going to be +1. Group 2 metals are not multivalent. They're always going to be +2. And of course, aluminum, zinc, cadmium, silver. Those are not multivalent ions. Okay, so let's look over here on the names. Okay, phosphorus. Okay, ignore this one. This one's funny. Anyway, this is actually a covalent compound, but it's going to be a phosphorus +3, chloride -1, and it's going to be PCl3. It's actually a covalent compound. But we look at zinc sulfide, barium chloride, because zinc is not multivalent. Barium's group 2. Strontium is group 2. Those are not multivalent. All right, now let's look at the formula side. Lead, multivalent. Tin is multivalent. Manganese, zinc, not multivalent. So this one's just going to be zinc iodide. It doesn't need a Roman numeral. Manganese is multivalent. Lithium is not. So this one's just going to be lithium oxide. Iron, yes, nope. Zinc is not. That one is just going to be zinc chloride. Potassium is group 1. It is not. So this is potassium fluoride. And the rest are multivalent. So all these others here are going to need a Roman numeral. All right? So work on the rest of the worksheet on your own. Check your answers against the key when I post it. And email me or IM me if you have any questions. So there's what the completed worksheet looks like. Let me know if you have any questions.